Hey guys, Mr. Backerberg here. In this video, we're going to look at the dividing out technique for evaluating limits. Direct substitution doesn't always work for evaluating a limit. So in this case, if we were trying to evaluate the limit as x approaches -3 of x squared plus x minus 6 all over x plus 3. If we tried to plug in that -3 for those x's, we would actually end up with 0 on top and 0 on the bottom of our fraction. And that's something called indeterminate form, which just means that we're unable to determine what the limit is based on the function the way it's written right now. But if we tried to evaluate things numerically, so looking at a table, if we approached -3 from each side, so if we plugged in -3.1, we would get -5.01. If we plugged in -3.001, we'd get -5.001. And as we gradually move closer to -3, here we get to -5.001. Well, if we approach -3 from the other side as well, it looks like as we approach -3 from each side, it looks like our limit is approaching -5. So this limit does exist. We're just not able to determine what it actually is based on the way our limit is written right now. So when we're doing dividing out, we're going to rely on some algebra that we've learned along the way. This top quadratic is actually factorable. This is going to factor into x plus 3 and x minus 2. And then the denominator is still x plus 3. And because we have that x plus 3 happening on top and on bottom, we're allowed to cancel that factor out. So this reduces down to just x minus 2. So we divided out that factor of x plus 3, so now we can evaluate the limit of what's left over. And if I do direct substitution now, if I plug in that -3, I end up getting -5, just like our table showed that we should get. So again, by canceling out this factor of x plus 3, we were able to come up with a limit that we could then solve using direct substitution. So taking a look at this example, we're trying to do the limit of x squared minus 7x plus 12 over x minus 4 as x is approaching 4. If I tried to direct substitute that 4 in for those x's, we would get 0 over 0, so that's our indeterminate form. So I'm going to try to factor out the numerator. So looking at what we've got, multiplying to 12, adding up to -7, that's going to be x minus 4 and x minus 3, and our denominator is still x minus 4. So I notice that those x minus 4s are going to cancel out. So now we can do the limit as x approaches 4 of just x minus 3. And then I can direct substitute that 4 in for the x, and the limit ends up equaling 1. Checking out this example, we've got the limit of x minus 1 over x cubed minus x squared plus x minus 1 as x is approaching 1. Again, if I tried to direct substitute that 1 in, I would end up getting 0 over 0, so that indeterminate form. So I'm going to try to do some factoring here. On bottom, because of that cubic, I'm actually thinking that we should try factoring by grouping. So if I make a group out of the first two things, the GCF there is x squared. So if I factor that out, I'm going to be left with x minus 1. If I make a group out of the second two things, the only GCF that I can take out of there is 1, and taking a GCF of 1 out doesn't change what's on the inside, so that's still x minus 1. When we're doing grouping now, the like factors become one of the pieces, and then the things in front of those factors become the other piece. So factoring out the denominator, we get x minus 1 and x squared plus 1. And we notice that the numerator is still x minus 1. So looking at this, the x minus 1s are going to cancel each other out. So we're going to be left with 1 over x squared plus 1. And now we can take the limit of that as x is approaching 1. I should be able to direct substitute that 1 on bottom. So 1 squared is 1, plus 1 more. Looks like we get a limit of 1/2 on this one. That's going to be it for this video. Thanks for watching.